Hey everyone, so in this clip we're going to be talking about how to derive one of the other very well known trigonometric identities, which is 1 plus tan squared of an angle equals secant squared of an angle. So how do we come about this conclusion? Well, let's go ahead and construct our triangle again with base x, height y, hypotenuse r, and some angle in between here like this. So the Pythagorean theorem will tell us that we can say x squared plus y squared equals r squared in this case. So here's where the trick comes in though. We're going to take this and multiply the whole thing by 1 over x squared this time. So this is going to get rid of our x's, so we're going to have just 1 here plus y squared over x squared equals r squared over x squared. Okay, so now let's go ahead and take the square out of both pieces because we're allowed to do this. And okay, so this is what we have. So a lot of you might immediately recognize that this is where the tangent goes, because we know that y over x equals the opposite over adjacent equals tangent of some angle. But how about this r over x? Well, there's something that we can refer back to called the trigonometric reciprocal identities. Maybe your textbook uses that exact terminology, I don't know. But okay, so let's say that we're going to take our r over x, and the idea here is that this can actually just be rewritten in a different form as 1 over x over r. Okay, so now this is just 1 over our adjacent over hypotenuse, which is 1 over cosine of the angle, which if you know your trigonometric identities, then you know that 1 over cosine of the angle equals the secant of that angle, which also implies that cosine of the angle times the secant of the angle equals 1, which also, depending on the question at hand, might be able to come in useful to you at some point. So now we can go ahead and substitute this back in. So 1 plus tan of the angle squared equals secant of the angle squared. But now we also need to be able to know that tan of the angle squared equals tan squared of this angle, and that's just like mathematical convention is all that is. This is a way to express the same calculation. And likewise, secant angle squared equals secant squared of the angle. And okay, so because of that, we can just say that this equals 1 plus the tan squared of the angle equals secant squared of that angle. So that's where that comes from. But also, at some point, you might have a question on your homework that requires you to know what tan is in terms of secant, or secant in terms of tangent. So how can we do this? Well, secant square of the angle equals tangent square root of the angle plus 1. So if we square root both of these, then we can come to the conclusion that secant of the angle at absolute value equals the square root of tan square of the angle plus 1. And you do a similar process for the tan square of the angle, and this gets us to secant square of the angle minus 1, and you square root to isolate the tangent, and we get the tangent of the angle can be described also as the square root of secant square of the angle minus 1. So this is this trigonometric identity, and hopefully you found that helpful, and I'll see you in the next one where Joe shows you how